Yeah, hi all, welcome. Today we are going to see one of the important topics called CNN. Let's wait for a few more minutes, let others also join. Just remind your friends, ask them to join. Many are yet to join, let's wait for 2 more minutes. Just remind your friends, ask them to join. We'll see how to develop CNN based, how to develop some CV projects, computer vision projects we are going to see. Yeah, before others join, if you have any questions, you can raise your hand, I will unmute you. Yes, Dinesh, unmuting you, you can ask your question. What's your question, Dinesh? Yes, Kumar, unmuting you.
Thank you
Many
so
are.
much. Am I audible?
Yes, you're audible, Kumar.
Thank you so much for creating this knowledge for us. So my question is, do we need to practice along with you, or else we just need to sit and understand
Just
the
see, first see it as a magic show. Please make a note of all these concepts.
Mhm.
Then you can practice after this session.
Okay. And please help us with the resources also, along with
Sure,
the.
sure. Just make a note
Thank
of
you.
all these concepts. You will understand and you can practice immediately. Okay.
Definitely, sir. Thank you.
Okay. Thank you. Yeah. Any others? If you have any questions, we have to cross at least 200 today. I'm just waiting for others also. I don't want anyone to miss the introduction. So if you have any questions, just go to reactions, raise your hand. I will unmute you. Okay, so today's concept is a roadmap for the contest on CNN. What is a CNN? What is this convolutional neural network? We are going to take image as an input, and the models are going to analyze the images, and it's going to predict something from the patterns of that image. Okay, our models are going to find some patterns, and it's going to predict something. For example, today, I'm just working with one particular college called PSR CMR, Vijayawada, Potti Sriramulu Engineering College. There, few students made some sort of CNN projects. For example, if you give a bone X-ray image, that particular CNN model is going to predict whether the bone is got fractured or not. If it got fractured, what is the location? That particular model they have developed. If possible, I'll invite those students from PSR CMR. They will exhibit their project. Few days back, another intern from KBN College, Vamsi, that guy name, he made another project. If you upload fundus image of an eye, that particular model is going to predict different kind of diseases, almost 5 different type of diseases, whether they do exist or not. This is another kind of CNN project. Most of you knows about this autonomous cars, right? Autonomous cars is also another kind of computer vision project. If you pay attention for next coming 30 to 40 minutes, you'll understand how to develop such type of models, CNN based models. After learning those concepts, what you have to do? You can be part of our upcoming project, upcoming contest on CNN. It's a long contest actually. August 15th will release the results. August 15th, we're celebrating 75th Independence Day. So on that day, we are planning to release the results. Our target, at least 75 different colleges should be part of this contest. The contest is, you have to make a model which can take image as an input. It should predict or it should identify something based upon that image. Got it? For example, if you take a picture of your X-ray of lungs, it should detect whether it is a healthy lung or if it is having abnormalities. It should able to predict like that. And another one, for example, if I take any picture of your, I'm preferring only medical actually. You can take a picture for your car also. Your model should able to predict what is the car model and which company that car and what is the year. All those concepts, your model should able to predict. Actually, for CNN, you can make such type of models also, but prefer medical based projects. For example, if you take a picture for your heart, it should able to predict something from that particular image. There is a concept, there is a specialized department in medical called radiology. Radiologist, what radiologist will do? Radiologist will analyze CT scans, MRI scan, and X-rays. They will find something from those medical images. If we train the model, on similar things, even our models also can do such type of things. Shall we start the program? Shall we start the program? Hello, just go to reactions, raise your hand if you are ready. Just go to reactions, raise your hand if you are ready. We'll see 2 to 3 different type of projects. Tomorrow also 7 to 8 we are going to have the session. Today part 1, tomorrow part 2. Okay. There are n number of models which are available to work on these kinds of CNN. First one, I like YOLO a lot. Let me share my screen and let me show you. I like YOLO a lot. Yeah. What is YOLO? YOLO is one of the fantastic object detection. One of the fantastic object detection model. Object detection is different. Classification is different. For example, first thing is classification. I'll tell you what is classification. With the help of YOLO, you can perform both. You can perform object detection. You can perform classification also with YOLO. What is classification? Classification means whether a particular problem exists or not, whether a particular, whether in that particular photo, dog exists or not, in that particular photo, cat exists or not. If we say that one, we call it as a classification. Second one is object detection. Both things we'll see. Okay, both the things we'll see. Object detection means in a given picture, where is the dog? Where is the cat? What are the coordinates of that cat? How much space that particular dog occupied? How many dogs are there? That comes under detection. Hope you're getting the difference between detection and classification. Classification means exist or not, true or false, whether dog photo or cat photo, whether cancer exists in that particular lung or not, comes under classification. Second one, detection, object detection, where the bone got broken, what is the area of the part. For example, if you give MRI scan of some brain, how much the size of that particular clot. First classification means whether clot exists or not, comes under classification. What is the size of that clot? What is the size of that? For example, there is any bleeding in brain. How much the size of that particular issue? That comes under detection. Okay, we can perform both with the help of YOLO. YOLO. You only look once is a full form of YOLO. Like YOLO, there are many CNN algorithms are there. Many algorithms are there. But as of now, YOLO is one of the best things for object detection. You can perform medical based with my internet. I'll make some of you as co-hosts. If there is any voice disturbance, just let me know. Some of you please raise your hand. I will make you as co-hosts. Hope I'm audible. Yeah. Some of you please raise your hand. I will enable chat also so that you can give response in chat also. Yes. Yes, Jayanti, I'm making you as co-host. If there is any voice disturbance, hope you have my number. Shiva, hope you have my number. You can make a call to me also. Yeah, making Prasad as co-host. Two more. Okay, done. If my net got disconnected, you'll become host. I will rejoin with my name, Sai Satish. You can make me host. Okay, at the time, just make a call to me if I get disconnected. Okay, YOLO is one kind of model you can use for object detection as well as for classification. Recently, YOLO 8 has been released. Very fast. YOLO is very fast, and its detection is not only training the model, even detecting a model is also very quick. See here, this is a small example of object detection. You can do live streaming on camera. Almost for 24 frames per second will be there. You can increase 30 frames for also. It's very quick. YOLO is very quick. We'll see some sample random examples on this. Remember this particular website called RoboFlow. With the help of RoboFlow, you can manage your data sets. You can train your models. With the help of RoboFlow, you can manage your data sets. You can upload all the images. The first thing is you have to create a data set. When you're making some computer vision projects, the first thing what you have to do is you have to make a data set. First thing is data set. The data set must be very good. It should be very accurate. If the data set is poor, or if the data set is having some errors, your model also makes some wrong predictions. So your data set must be good. So what you have to do, for example, if you want to make a model which can predict whether a lung is having a cancer or not, then what you have to do, you have to capture at least some thousands of lung cancer images. Take lung cancer images. Where to get those lung cancer images? You have to request some hospital or doctor to get that particular data. Otherwise, other option is you can use data search engines like datasearch.research.google.com. This is a data search engine. This is a data search engine. Just give me a minute. Just give me Yeah, I'm back. The first thing is you have to manage, you have to maintain, and you have to create or you have to collect the data. And it should be labeled. First thing is collect the data. Go to hospital, talk with them, request them, and make sure it is compliant. If you collect someone's health record without their permission, it is crime. We have to take written permission from even from patient also. Anonymously, also, if you wish to collect, you have to follow some compliances and follow those guidelines, talk to hospitals, collect the data. If hospitals are not, if they're not sharing the data, anyways, we have the data set search engine like datasearch.research.google.com. Here also you can search, for example, search with lung cancer. There are plenty of data sets are available. Thousands of data sets will be available. In every data set, thousands of images will be there. See here, this data is from data.world. It is CSV. And I don't think this is CNN based. Just keep on searching. Somewhere you can find the images. Somewhere you can find the images data set. Okay. After this, after collecting the data set, even RoboFlow is also having one of the fantastic data sets repository. More than 1 lakh data sets are available in this RoboFlow. We can give a try for 1 or 2. I'll show you how to perform all these concepts now. Hold on for 5 to 10 minutes. You will learn how to build one CNN model. Just wait for 5 to 10 minutes. Create an account in this website. Explore a concept called universe. In this particular link, you can find public data sets. More than 1 lakh data sets are available. See here. Oh, not 1 lakh, 2 lakh plus data sets are available. Just select one of the targets, object detection or classification. Let's select, you can try both, okay? Object detection. For this contest, I recommend you to work on medical-based projects because our society is AMR. I strongly recommend you to stick medical-based data sets. This is our society. We have to work on medical-based AI stuff, okay? Coming back to our object detection, see here, glasses detection. No, we don't want this. I don't want this also. I don't want this. I don't want this. No, badminton. I don't want. Lakhs of data sets are there, but I want medical data set. Let me search for bone. Bone. Some data sets are available. 109 images. See, in while training the model, having more number of images is very, very important. If you have less number of images, it will be poorly trained. Okay, that model will be called as underfit. If you have more and more number of images, it may become overfit. On an average, I do recommend generally 3,000 images or 5,000 images are also okay. 5,000 images are also okay. It is having only 100 images. Model may not be accurate. If you want more accuracy in your model, make sure you are having enough data set. Enough images in your data set. 5,000 images, chalta, no problem. See, this data set is okay. 700 images are there. And make sure it is labeled or annotated data set. If it is not annotated data set, it is useless for us. What we do with unlabeled data, they must be labeled data. That means, for example, if we take this particular one, it will show whether this particular one is broken or not. It will show you where that got broken. See, fractured. In the whole image, if this is the image, here the fractured part is there. See, fractured part is there. Let's go to the next one. This is labeled. Got it? This one is labeled. Perfect. Where it got fractured? In this area, it got fractured. It is labeled exactly. It is detecting where it is. You have to figure out such type of data sets. If it is, see here, 2 places. In these 2 places, it got fractured. How many images are there? 40 images are there. Oh, bad, sad. At least if we have 2000 such type of images, we can make something realistic. You can train with 40, not an issue. You can train with 40, no objection. But if you have more number of images which are properly labeled, then accuracy of our model also will be good. Okay. Okay. Number of things are here. So first come to universe. Select your desired project. Otherwise, you have to create your own data set. Classification, let's select classification. Let's see the data sets. Now in classification, I want to see something related to medical. Let me search with the word medical. Okay. 409 data sets are available, it seems. 409. Just keep searching. I want to search for any lungs. Lungs. Yes, but 45 images, no use. Oh, good number of images are there. 5,000 images are there. You can give a try. Lung segmentation, 15 images, not that much great. You can try with this data set. If the labels are accurate, then you may get very good predictions. Okay. So hope you got the data set location, right? Data set. First step is get the data set and make sure it is labeled. If it is not labeled, you cannot do anything. So few years back, I made our own project also, which is chess detection software. If there is a chess board, if we place the chess pieces, our model should be able to predict the pieces. That is one of my targets. Let me show you the data set. I myself captured all these pics. I captured all these pics. Let me show you a sample one. Around 1000 images are there. First, upload all the images. Okay, upload all the images. And you have to start labeling. If you're a radiologist, surely you know whether upon that particular image, surely you'll understand something from that particular medical image, right? If you're not radiologist, import some random label, random data sets. Hope my voice is clear. Please acknowledge in the chat box. Hope my voice is clear. Please acknowledge in the chat box. Okay, perfect. See here. You can start assigning annotation. First, upload all the images. Okay, let me randomly upload some images. Okay, so I think those images. Yeah. After uploading the images, you can see image like this. What you have to do? Take this tool. Take this particular tool. This tool is for labeling. You have to label. First, we have to train the model, which is a rook, what is a white rook, what is a black rook, what is black queen, what is a knight. You have to train. If we don't train, our model cannot understand anything. We have to train. Okay. Select place from here to here. Select white rook. White knight, sorry, white knight. Select here. If you want to label this one, don't double label. I'm just doing double labeling. You should not double label. One time is enough. For example, if you want to label this, let me delete this. Let me delete. Yeah. This is what is this? Black rook. If you want to label this, by default, it got selected. Select from here to here. Now black rook. BR, black rook. Okay. Let me delete this. This is what is this? White bishop. By default, it got selected. Click here to here. White bishop, WB. Select this. Like this, you have to label. Okay. First step is data set. And your second step is annotate it. Annotation. Label it. Okay. You have to label. Make sure it is 100% correct. If you make simple mistakes, your model is going to learn those mistakes and it's going to impact a lot while predicting. Investing time and money on data sets are very, very important because training the model is very simple. Based upon total number of images, based upon your hypertuning parameters, it will get trained. Data set plays very, very important role, and accuracy in your data set plays very, very important role. So data set must be accurate. Take time for labeling them. For object detection, you have to label where the dog is, where the cat is. For today, just try some cat data set will be there. Cats and dogs. Let me search cats. Surely some data set will be there. Cats. Oh, some cancer related breast cancer classification is there. I don't want classification now. I will go with object detection. The two cats and dogs. Very simple data set. It will be available. Okay. Yes, cats detector. 55 images are there. Very less. Filter so that you will get more number of 833 images. You can give it a try for this. Cats. Okay. Okay, let's try with this data set images. Shall we try with chess or shall we try with cats? Suggest something. Chess or cat? Which one shall I try now? Chess pieces or cats? Many are saying cats. Many cat lovers are there or what? Many say. Okay, 4 people are saying chess. Almost 60 people are saying cats. Okay. Cats. I don't own this cat data set. I don't own it. You can click on download data set. Okay, see here. Download data set you can use. I'll show you both. Both are almost same. Okay. For example, if you want to try in this cats data set, open this, click on download data set. We are detecting cats. We are not classifying the cats. We are detecting the cats. Okay, keep that in your mind. Select the format, select YOLO 8. YOLO 8 is very quick when compared with all other models of YOLO. YOLO version 8. Select that, click continue. Now it's going to show us a small code. Copy this code. That's it. Copy this code, paste here. We got the code. That's it. Nothing more than that. Now we are going to train our model which can detect cats. Okay. Now choose a model. Click here. Choose a model. YOLO 8. Select Jupyter Notebook. Okay. Otherwise, let's do one thing. We'll see with Colab. Hold on. We'll go to Colab. Come to RoboFlow. Explore the models. Explore the models. Hold on. Models library will be there. Models library. Hold on for a few seconds. We're going to see models library. Segmentation, few models are there. For classification, different models are there. For object detection, different models are there. Some models you can use for both classification as well as for detection. See here, model library. You can find model library. Click here. See what you can perform. All these things you can perform. Our target is not classification. Our target is not to find whether cat exists or not. Our target is to find where is the cat. Where is the cat is our target. Okay. So select object detection. 19 models are there. Here is the list of those models. YOLO 8 and another model, old version of YOLO, Detectron. These are different kind of models you can try. All are CNN only. Okay. Let's select YOLO 8, which is very fast. It takes few minutes for training. We have to wait. After that, we are going to inference the model. What's the word I'm using here? Inferencing. Inferencing means we are going to send some images to the model and we are going to see the response of those models. Yes, YOLO 8. Where is our Colab link? Search. Where is our Colab link? View on GitHub, SageMaker. Here is our Colab link. Click here. Open our Colab link. Few minutes back, we copied something, right? This one. Keep this safe. Within 20 minutes, Disha, it's already live streaming in YouTube. A lively 201 participants are there, excluding me, total 202. It's already recording in YouTube. You can see it live later. Soumita, repeat last few steps. Which step you want me to repeat, Soumita? Yeah, while getting trained, it takes time. If you want me to repeat, while getting trained, I'll repeat, okay? I'm using Colab Pro here. I'll have more RAM. I'll have dedicated GPUs also. Anyways, you can try in free also. Colab free version also you can try, not an issue. Because when we are not going to play with 40 billion NLP models or 120 or 50 billion NLP models. So Colab free is also enough. For video dataset, which model you use? Same YOLO, same. CAT dataset name. I don't know what is this dataset name, Soumita. Just CAT dataset for the first time. It's initializing. Wait for a few seconds. Come and run these lines. It will show our configuration. Srinivas sir also joined. Welcome you, sir. Please unmute yourself. Oh, sorry, there is some network issue. Srinivas sir, welcome, sir. Please unmute yourself, sir. Srinivas sir. Lakredi Baladi College.
Good evening, sir.
Good evening, sir. Sir,
you,
instead
sir.
of using Colab, we'll use our servers from next time, sir. I'll make you as co-host, sir, so you can unmute yourself anytime.
Sure, sir. Thank you, sir. Thank you. Definitely we'll use it, sir.
Thank you, sir. Thank you, sir. So we are using cloud as of now. You will get this GPU for free of cost for few minutes, around 12 hours. You can get for free of cost. After that, you can restart and you can try also. So this is a server configuration what we got. I'm using Colab Pro. You no need to use Colab Pro, no issues. So current working directory is content. Current working directory here. So let's install YOLO 8 version. YOLO 8. It takes 1 or 2 minutes. You don't need to write a single line of code also here. Everything will be there in this particular notebook. Just open the notebook. Just check the commands. And run one by one. I don't want CLI command line. I don't want. Let me remove this. I don't want this also. Yes, install this. I don't want this also. Anyways, can run, no issues. I don't want this also, no need. Directly jump to this location, RoboFlow universe. Here, what you can do, 1 second. Oh, screen is not visible. Sorry. Hope it is visible now. Okay, let me show you from back. Come to workspace. Left side, you can see model library. Okay, hope screen is visible now. Hello, co-hosts. I made you co-hosts, right? You have to inform me. Co-hosts, you have to be active. You have to inform me when I make such type of things. You have to inform me. Jayanti, Prasad, inform me, okay? మెసేజ్ చేయడం కాదు ప్రసాద్, అన్మ్యూట్ చేసుకొని చెప్పాలి ప్రసాద్. నేను చాట్ చూడట్లేదు, ఓకేనా? ఏదైనా వాయిస్ డిస్టర్బెన్స్ వస్తున్నా, నెట్వర్క్ ఇష్యూ వస్తున్నా అన్మ్యూట్ చేసుకొని నాకు చెప్పండి, అలర్ట్ చేయండి. Okay. So here in this particular website, you can find model library. Open this. So some tens of models will be there. Around 40 different type of models will be there. Our target is latest version of YOLO, which is 8. And our target is object detection. So we'll select object detection models, object detection. Among object detection, we'll select the latest model, YOLO. Okay, here Colab link will be there. Just click here. That's it. This link will be opened. Now, just I'm using Colab Pro as I mentioned earlier. Colab Pro, you can use free version also. Here is the configuration details of the server what I'm running. Right now, Lucky Reddy Baladi College is having similar server, Tesla T4. They're having M10, okay? Very powerful GPU server. Install this YOLO libraries. You don't need to change a single line of code also. Just run. Okay, just run. Don't work on this. No need to execute this CLI. Scroll down. Run this also. Oh, 1 second, guys. Yeah, I'm back. So scroll down. The only thing, just see these screens. Very simple, you know. AutoML. Very simple. Scroll down. Here, these four lines you have to change. That's it. These 4 lines. From where you can get these 4 lines? Few minutes back, we copied. If you open any data set, if you click on export, you will get these 4 lines. Copy that. It is in my notepad. Copy, paste here. Just replace this key. Okay. Just replace. I already installed RoboFlow. Anyways, run this. So if you observe here, the data set will be downloaded. All those training set, validation set, all those images will be downloaded to your Colab. Wait for a few seconds. It's getting downloaded. I don't know the accuracy of that image. Anyways, if accuracy is good, we'll get the best. It's downloading. Hold on for a few more seconds. We are doing for cat images. You have to do for any medical data. Same way. If you don't like YOLO, try other one. You don't need to stick to YOLO. CNN you can try with YOLO, but you need to stick with YOLO itself. Okay. Yes, see here, a lot of data is ready. Scroll down. That's it. Start training. This is the line for training. Training. Okay, wait. Not this one. Hold on. Yes, just click here, F25. If you increase this epochs, more times it will be iterated. Okay, epochs is 25 here. If it is less, model will not be accurate. If it is too much, 2000, model will maybe overfitting or model will not respond properly. It takes more number of iterations. So epochs 75, 100 is also okay, but it takes a lot of time if you mention 75 like that. So we just mentioned 25. 25 times it will be iterated. Okay, still going on for the first time. First one not completed. I don't know how much time it takes. If there are less number of images, it will be very quick. Let me check. GP is also getting increased. Still we are 1 by 25. I think it may take 30 minutes, I think. We can stop also. We'll get best trained model. We can test. At least let's finish up to 5 by 25. Okay. 78% finish. It's taking almost 1 minute per epoch. 25 epochs we have mentioned. So it takes 25 minutes. Let's wait. Let's check. Okay. Almost 93%. Okay. Oh, it takes more than that. More than half an hour it takes. Second epoch started. We have to wait. Okay. No other choice. Model is getting trained. So meanwhile, you also give a try. Meanwhile, you can also open your Google Colab, create an account in RoboFlow. Yeah, each epoch almost same time. Yes, Ahmad. So we have to wait. Here in runs, we can see the weights also. Weights files will be there. Yeah, here it is. Best and last is there. After reaching 5, I'll stop. Okay, we'll test these two. Actually, we have to wait up to 25. Then get the
Sir,
best.
voice was not audible.
Otherwise, prediction may be not accurate. Voice not audible. Is it the same for others also? Is it
No, sir.
voice breaking?
Just
Okay.
now it was
Others
okay.
also.
Now it's clear, sir.
Audible, sir. Now
Is
it's
it clear now? Okay. So you also please give a try. Just go to the website called RoboFlow, find some random database and start epoch. After 5 epochs, I'll stop this. Okay. Still 3 by 5. Let's wait for 2 more minutes. If you stop like that, you don't get accuracy. For chess, I have trained 48 hours, you know. Colab works only for 12 hours for free. For Pro, 24 hours. But I made for 48 hours. Do you know how? I trained the model. After few hours, I copied the best, last, and training parameters. And next day, I started from where it got stopped. Okay. Will the YouTube link is shared, Shivani? Yes, Shivani, you can search Aimer Society in YouTube. You can find in live. We mentioned public only. Let's wait for 2 more minutes. It's getting trained. The same thing you can try for bone fracture. Bone fracture also you can try. It's going to predict where the bone is, where the fracture is. I want everyone to make a UI. Doctors will upload images in that UI and your model should predict where it is. It should give some response. Okay. How many epochs you use? I don't remember. Almost 1.5 years back we did. 1.5 years. But my accuracy at that time was almost 99%. Saumita, just key error means just check what you're copying and what you're pasting. Just check what you're copying. Let's stop after fifth one. Takes 2 more minutes. Best and last model is ready. Let's wait. Yes, almost done. After this, we'll stop. Okay, we'll stop and we'll inference the model. Meanwhile, let me download some cats and dog images. Cat and dog images. Shall we select this? Downloading this. Yes, Firefox done. I'm stopping this. Okay. You should not stop like this. Scroll down. Let's check whether training is there or not. Okay. So here, how our model got trained, whether it got any issues or not, that information, map information that will be displayed here. I don't want to see all these things. I don't want these things now. Let me go and check the validation part. Validating our custom model. So some test images are already there here. Test images are here. Test images. We can check these test images. Otherwise, single image also you can give it a try. Single image also you can give it a try. So here is a folder name we have mentioned. Test images. We'll test all these images now. Here there are some tens of images are there. See, done. Within 2.3, it took around this much time to process image. See here, 2.3 milliseconds. Fantastic, right? Now let's see those images. I want at least 10 images. Those images will be printed here. Okay, name is not predict 3. In the detection model, there detect runs detect predict. Yeah, just remove this 3. Remove this 3. Print. The predictions are here. Hold on, they'll be printed. Yes. No, it failed to identify. Cat is here. our model failed to identify. Don't expect accuracy. Oh, we got here 0.33% confidence. It could able to identify the cat here. Very good. Yes, cat has been identified. Very good. Cat identified. Good. Very good. Here also it identified. Good. Here it is detecting as cat. Is it cat? No, I don't think this is a cat. But it is saying some cat is there. Is it cat or what? Guys, is this cat? See here. Do respond chat box. Is this also cat? Do you have two cats or one cat in this picture? Not cat, right? But it is saying it is cat. Accuracy is less anyways. Cat. Very good. Again, cat. How many of you like this? A simple CNN model, cat identification. How many of you like this? Raise your hands. Okay, tomorrow we'll see a few more concepts in this. So tomorrow you have to complete these tasks. Whatever we have discussed here, just complete these tasks. Tomorrow we'll see how to integrate these kinds of models in your Telegram and how to inference the models. Also, we are going to see tomorrow. That's all for today. If you have any questions, just go to reactions, raise your hand. I will unmute you. You can ask me questions. Yes, Shajita, unmute yourself. Yes, Shajita, you can ask your question. If anyone wish to ask questions, just go to reactions, raise your hand. I will unmute you. No doubt. Okay. Prem, video is already streaming in YouTube. Just open YouTube, search with our Aimer Society. Okay. Just go to videos. It's getting live streamed, so you can watch here. Okay. Prem, just go to this our channel. Go here. In this, you can find live videos. There you can watch. Here in this link, you can watch this video. See, this is our video. What is this called as in functions? Tell me. Calling a function itself. What is it? How can we apply it on video to predict? 4229 is asking res recursion. Yes, 4229. If you want to add on image, do one thing. See, there is nothing difference between video and image. For example, for image means it's one image. Video means per second 24 images. Okay, you can give input. Web camera also you can give as an input. Video also you can give as an input. No need of image. You can give videos also as input. Tomorrow I'll show you. For video also tomorrow I'll show you. Okay. Okay, guys, that's all for today. See you tomorrow. Bye all.